need some data that can be stored, or it can be you want to read it, or you might want to save it in a textual format, say .txt, or you want to put it in a .csv file. So in such cases, we can go for the option of reading and writing the data or the array data from external files. So today's presentation, we will see how we can read and write array data on files using NumPy, which is a fundamental library for numerical computations in Python. We will see how we can handle large data sets. We will try to use the advanced powerful functions of NumPy, like saving the data, saving the file, loading the file, and manipulating the data which is stored in various file formats. We will also see how we can read tabular data. We will also see how we can handle the missing values. We will try to extract information from structured arrays. So let's get into the details. So let's first learn how we can load and save the data. Let's take a simple example. Let us first create the data in our system. Next, we will see from an external file. So suppose I have created an array like this in the code, np.array, which we have seen how we can create arrays. So after we create the array, we will save this in a file. So let's say the data is in a variable called as data. So now this we are going to store it in a file. Let's call it as saved_data. Now later we will use the load function in NumPy to access this data. So let's try this on the Jupyter notebook. So go to the Jupyter notebook. Let's create a new notebook. Now let's first import the NumPy. Shift enter. So now let's create a array. Data is equal to, let's say, open the parenthesis. Now let's keep the data within the square bracket. So that means I'm going to have list. Now within that, let me just create 2 rows of data. So 2 square brackets. So in the first one, let me say store some random numbers like this. And similarly in the next row, we will also put some more random numbers. So basically I'm trying to let me create one more row. So 1 more square brackets. Okay, so now execute this. Okay, we did a big mistake here. We have to put here np.array. Okay, so now let's execute this. See, this is the array that we have created. Now let's use the save function from NumPy, np.save. I'm going to store this data variable in a file. So let's call the file as saved_data. Put that in the quotes, comma. Into this file, I am going to, from whatever the content is there in the data variable, now that would be saved in this saved_data. And by default, even though if I don't give any extension for this file, by default it will store it as .np. Shift enter. See, now what has happened is there is all these data has been stored in the file called as saved_data. You can go to the home page and see there is a file created here called as saved_data. It's here. See, so a file called as saved_data has been created now in our system. Now let's see how I can now access this. After saving the file, let's see how we can access this. As I told you, by default the extension .npy will be added to the file. So how do you access the file now? Using the np.load command. So let me put it into another way. So I'll put the contents of this file, into loaded underscore data, and I have to use the command now np.load. Now you specify the file name. So the file name is saved underscore data.npy. Now when you execute this, shift enter. Now let's see what's there in loaded underscore data. You can see the data is now retrieved. So this is a very simple example where what we have done is we have created an array, and that content of that array is stored in a variable data. Now from that I have put it into an external file called as saved underscore data. By default .npy will be added and it will be saved in our file. Now I can access the contents of this file by using the np.load. That means I'm importing or loading this data file saved underscore data.npy, and whatever the contents is there, I'm adding it to the variable loaded underscore data. So now let's see another example. So suppose I have some files which is in the .txt format or .csv format. Now what is .csv format? .csv stands for comma separated value. So that means I will have some values here which are separated by commas. So suppose I want to access such files, then how do I do it? So let's first create a CSV file. I'll show you how we can create a CSV file, and then we will use a function called as np.gen from text to access the file. Okay, so now this is what we are going to do now in the Jupyter notebook. So I will just delete these things. The same file I'm going to create. Okay, so now what we are going to do is let's first create a CSV file. So how do I create a CSV file? Just open a notebook or notepad. So in your notepad, a simple notepad, just let's create a simple notepad. I'll give some headings called as ID. I'll just increase the font size of this. Okay, so let's give the contents. Let's say these are the headings of the columns: value 1, value 2, value 3. Now in the next row I will just give some values, 1 comma, let's say the value as 1.33 comma 2.33 comma 3.33. This is the next row. I'll give the ID as 2 let's say 4.33 comma 5.33 6.33. Like this is a third row. I will give 7.33 8.33 and 9.33. Now I'm going to store this. Right, so now where am I going to store it? Right, so I have to now store it. Let's first store it. I will just store it in my system and then I will upload. You can also do that. So I'll just keep it on my desktop and let me give the name as let's say data1.csv. Okay, so why is it CSV? Comma separated values, because all the values I'm separating by commas. So data, and as of now I put it in my desktop. Now what you can do is just go to your home page here. Right, this is a home page of your Jupyter notebook. You can upload it. You can also upload it from here. See, you can also create here. So if I say new text file, even here I can create it. Or after you create, or if you have already created and it is there in your system, so just go to upload. That is also possible. And just upload it. See, after upload, you get something like this. You click on this upload button. See, now you see data1.csv is there in my system. Okay, now go back to your program. Now let's write the program to access this CSV file. See, first thing is, to accessing the CSV file, we need to use a function called as np.gen from next. So this is a NumPy function which will read textual data and creates an array. Okay, and it has a particular syntax. It has quite a lot of arguments. Gen from text can take quite a lot of arguments, but we are just interested in these 3 arguments, which is enough that you can just take. Okay, so the first argument that I can give is data.csv. that is the file which I want to upload. Okay, so that is compulsory. Like rest of the arguments are optional depending upon what you want. See, I have to specify the delimiter because in my case the values are separated by comma, so it has to differentiate, right? So 1 is the next one, id is the first one, next to value 1 is the next one. You need to differentiate, so that's why delimiter has to be given. Suppose I have separated by the values by space, you can give a space. In my case, my notebook, I had separated the values with a comma, so that's why I'm giving here comma. And names is equal to true. Now what is this names? In if I give it as true, that means I am column headers are present here in the system. If I use none, we will see that in the execution what difference it makes. We will see it. Okay, now let's create it. So let's use the gen np dot gen from text function. Now the first argument, as I said, should be the file. So the our file is data1 dot csv. What is the next one? I'm going to use, I'm going to specify the delimiter. Delimiter in our case is a comma because our values are separated by commas. Next, I have one more thing that I'm using, names is equal to true. See, if you actually go into the help, you can see that there are a lot of arguments that you can give for gen from text. You just use which is necessary for you. Of course, the first argument, that is the file name, is compulsory. The rest ones are depending upon your need. Okay, now let's execute this. See, now if I just want to display this data, see here what has been displayed. This is the first row, the contents of the first row. This is the contents of the second row and the contents of the third row. And see, D type is coming here. What is the D type? I had specified the headings, right? The headings for our columns. The first heading I had given was ID. If you open the notepad, this was the heading I had given. The heading of the first one was ID. The second one was value 1, value 2, value 3. So that is what is coming here in the D type. So the headings with the respective unique IDs. You can also access the columns. You can access the column IDs, first column with the index ID, or I can also access using this F8. Okay. Know suppose if I make, that is why we have here names. So what is the names is doing here is, if you want to know the column headers, then I have to give the names as true. Suppose I give this as none and execute. Try this. Execute this, execute the data. See what has happened? When I made the names as none, the column headers is becoming NaN. That means not a value. That means it is not considering the column headers. That's all. Okay. So if you make as true, it's going to consider the column headers. Otherwise, it will keep the column headers as NaN. That is not a value. So I'll make it as true. Fine. So now what we can see here is we have got a structured array in which the column headings have become the names of the field. Okay, we are the common column headings. Now let's Now suppose I have some kind of missing data in my file, right? It's possible, that's very much possible, especially in real time. Now in this case it's very simple. I can easily see that if any value is missing, I can try to put or whatever, because we just have 4 rows. But in real time the data will be like extremely huge. Right? And upon this data, suppose you do some kind of mathematical calculations and the values are missing, then it can lead to lot of wrong interpretation of the result. So that is why you have a concept called as NaN, and gen from text function is very useful in such case because it can handle missing data within the file. This is very important. When we go for AI or machine learning, we will be dealing with 10,000, 20,000, 30,000, sometimes lakhs of data in our file. It is manually impossible to see which data is present or not. Just by using this function, the function will take care of it. Just use this simple function in your code. It will replace all the missing values by itself with a variable called as NaN, with a value called as NaN, which stands for not a number. Therefore, the wrong interpretation that we may possibly do will be avoided. Okay, so let's see this. what we will do now is, see, this is our file. Now what I will try to do is, I'll try to remove this value. I'll just remove this value. Just remove it. That's all. 2 commas are there. There are 2 commas here. Okay, I'll just remove this. So 2 values I will just try to remove from the first row and from the second row. I have repainted the comma, and let me save it in data2.csv. I'll keep this in data2.csv. Now go back to your Jupyter notebook. I hope you understood. What I have done is, in the notepad I just removed 2 elements or 2 values from a CSV. Now I have to upload this, right, again into our home page. So just go to this upload the data2. I have stored it in a separate file called as data2. Upload this. Okay, so now you can see here data2.csv is uploaded here. Now I'll just change the code here. I will just change this to 2. That's it. Okay, now again execute every row. See what has happened here, right? What happened? Gen from text option took care of the missing value. See, I had removed the second element from the first row, and now that is replaced with a NaN. Okay, and here from the third row also I removed 1 element, and that is replaced with a NaN. So who did this? Gen from text function took care of this concept. So it's a very important function of gen from text function in NumPy. Now suppose you want to access some of the elements, right? We have already discussed about how you can access the elements of a structured array in the last session. So just to revise, suppose I want to access all the first, I want to print out all the first column elements. So what you do? Just say data, and then you just type here, what is the ID of that first row? Index ID. So just type here ID. Okay, you have to give it within single quotes. That's why you're getting this error. Okay, see, by giving the column header, I am able to access the elements of that particular column. Let's say value 3. See, all the elements of the third last column we have displaced. Let's say value 1. See, all the elements of the second row we have, second column we have been able to display. Okay, now instead of using these IDs or what we call it as labels of the column, we can also use numbers. So I can say data of 0. So when I say data of 0, you can see what is actually displayed here, the row numbers. Okay, if I give data of 1, I can see the second row. Then I can say data of 2, I can see the third row. Okay, so if you want to access the rows, you can just give 0, 1, 2. If I access the columns, you can just give the IDs. Let's also try, yes. So this is it. So please try all these examples to quickly revise what we did in today's session. Is we try to create, we'll just go back to the session and quickly revise. This is not the one. One second. So what we have tried to do in today's session is we created arrays, and through the structured arrays we tried to see how we can use load and save function. Then we saw how we can access the tabulated data using generate from text function. We also saw how we can handle missing values, and we also saw that how we can access the column elements and how we can access the row elements. So what we can conclude is, so far this is the last session of NumPy in the series. So far we have seen, this is actually the 11th series exclusively for NumPy library. We saw 11 sessions of NumPy library functions, and what we can conclude that is it's a very powerful tool. It is very good for scientific computing and data analysis, especially very good for performing complex operations. Please go through all the concepts, all these 11 sessions of NumPy exclusively, where we have gone through each and every function through programs, right? And we can see that this NumPy is a very good tool, tool it provides, not only for computations or scientific computations, but also for saving, loading and manipulating data which are stored in files. So in the next session we will see one more powerful library, that is a pandas, which is built on NumPy, and it offers even more advanced features for data analysis. Thank you.